In this video, I'll teach you how to solve projectile motion problems and the approach you should take. So, first problem, you kick a soccer ball off the ground with an initial velocity of 20 meters per second, and it's kicked 30 degrees relative to the ground. The only force acting on the ball is gravity, and we're going to ignore air resistance. How do you find the max height the ball will reach? Let's start with a diagram. At the start, it gets kicked up at 30 degrees, 20 meters per second. And then it's going to fly through the air, like this. Obviously, these will all have their own vectors. Of course, we also have the acceleration being gravity. Okay, step one, we're going to resolve the initial velocity into its components. So the y component and the x component. His x component, so the horizontal velocity initially, is given by 20 times cosine 30, which is roughly 17.32 meters per second. And if you're a bit confused, this is the initial velocity, 20 meters per second. And this is the angle at which it was kicked up at. Same with the initial vertical velocity, but with sine. This is 10 meters per second. Now let's decide our time interval for finding maximum height. Our time interval will be from the time the ball was kicked to the time of max height, which is right here. Here's a very important detail. At the peak of its height, the vertical velocity will be 0. It will only be traveling horizontally at that time for one very brief instant, and that's what we're going to find. There's an equation, and it's v y0 minus gt. We can rearrange this, and we'll get t equals v y0 over g. So there's our time equation that we're going to use. We plug everything in, 10 meters per second, take it from here, and g is just 9.8. You get roughly 1.02 seconds. So there's our time value. So at 1.02 seconds, he's at his max height, the ball. Now let's find his vertical height or vertical displacement at this time. Let's use one of our original kinematic equations. Y equals v y0t minus 1 over 2 gt squared. Let's go ahead and substitute this for t. And you end up with y equals vyo times vyo over g minus 1 over 2 g times vyo squared over g squared. When you go and expand all this, which I'm not going to do because it's a lot of steps, you get this very important equation, which is also on the cheat sheet. It's y equals vyo squared divided by 2g. This is the formula for maximum height. Go and plug your things in. So 10 meters per second squared over 2 times gravity. This is roughly equal to 5.1 meters. There, done. That means this maximum height here is 5.1 meters. Now let's take the same situation but calculate the time it takes to return to the ground. So basically the whole trip. Our time interval would be t equals 0 seconds, so right here at the start, to the time he lands, which is what we're looking for. Now the initial height is equal to 0, and the ending height is also 0. So let's write out our equation. We're going to use this equation again, which is for displacement of y. Let's plug our values in. So remember, ending y is 0, starting y is 0, it's v y0t minus 1 over 2 gt squared. If you factor out t, you can actually get this equation here, which is t times 1 over 2 gt minus v y0 equals 0. This is a quadratic and there's two solutions if you use null factor law. The first solution is that t equals 0, which is correct because here when y is 0, t is 0. The second solution is for the second y equals 0, which is what we're looking for. The second solution, when you rearrange it, is t equals 2v y0 over g. This is an important equation, and we're going to use it later on as well. Plug in our values, so 2 times 10 meters per second over 9.8, and it's roughly 2.04 seconds. So this entire trip for the ball took 2.04 seconds. I've made it a bit smaller because we need some space. Let me introduce to you a very important concept. It's called the level horizontal range. So the level horizontal range. The level horizontal range in this situation would be the total horizontal distance traveled. That is what it is. Now there's an equation for it. Let's call it R. The level horizontal range is R. And it has a formula, and it applies when a projectile lands at the same level that it started at. Now if this range is the total x distance, then we can say x is equal to R. And if you remember your kinematic equations, x is equal to velocity times time. Now let's substitute in for time that small formula that we found earlier. 2v y0 over g. This equals 2v x0 v y0 over g. And if you remember, this is equal to v cosine, and this is equal to v sine. So that means that it can be written as 2 initial velocity squared times sine times cosine. And remember, that comes from the formula for the x component and the y component. This divided by g. If you remember your trig, then you recognize this as an identity. So in the end, we can write it as r equals initial velocity squared times sine 2 over g. This is your formula. This is the important formula. And there's two variations, this and this. These are what you need to know. If you're going to write something down, you can skip all of this, just make sure you have this down. Let's see this in action. Let's use it for our football example. So from our previous calculations, we know the total time this trip takes is 2.04 seconds. And the initial x velocity was 17.32 meters per second. So the level horizontal range, or the total horizontal distance traveled, is equal to this multiplied by this, which is roughly 35.33 meters. Here's the final example for today, and it's a pretty tricky one, but it's also really awesome. So you are a military engineer, and you are tasked to design weapons. Right now you're making high-tech artillery, and it's designed, let's say it looks like this. It's like a cannon, okay? And it shoots a projectile at something 320 meters away. When something is fired out of this thing, it's fired at a fixed velocity of 60 meters a second. What is the best angle to fire this weapon at to make sure you hit this target? That's the question. And of course, ignore air resistance. Remember, our horizontal range formula is this. So let's draw a mini diagram. This is where we shoot our thing. This is where we want to end up. The distance in between is 320 and the starting velocity is 60 meters per second. We need to find the angle. This is a good start. We know the range is 320 meters. We also know the initial velocity is 60 meters per second. And g is of course 9.8 meters per second. And we're looking for the best angle. Now here's what we're going to do to find the angle. We're going to rearrange this formula for sine. And then we're going to plug everything in. So when you rearrange it for sine, you get sine 2 equals range times gravity over velocity squared. This is 320 times 9.8 divided by 60 meters per second. Use the inverse sine function and then divide by 2. And you find that the best angle to hit this target is roughly 29.92 degrees. By the way, something that really helps me is having all the formulas you ever need in one place. And I make these cheat sheets for myself, and if you want your own, it's in the description for free. So go sign up.